The James Webb Space Telescope is an infrared optimized telescope that can also view visible light. It's mostly designed to view galaxies from the early stages of the universe, and is projected to succeed Hubble in the year 2018. The reason that the James Webb Space Telescope is mainly infrared is because it helps us view objects that are redshifted and moving away from us, which allows us to see more distant into the past. This will allow the James Webb Space Telescope to view things more distant in the past than Hubble ever could. The main instruments of the James Webb Space Telescope are the Science Instrument Module, the Trim Flap, the Solar Power Array, Earth Pointing Antenna, Spacecraft Bus, Star Trackers, Multi-Layer Sun Shield, Secondary Mirror, and Primary Mirror. The Integrated Science Instrument Model is the most important part of the James Webb Space Telescope. It consists of the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor. The near-infrared camera will detect light from early stars and galaxies in the process of forming, the population of stars in nearby galaxies, and young stars in the Milky Way. The camera contains coronagraphs, which lets astronomers observe dim objects that surround a much brighter object. The near-infrared spectrograph is used to disperse light gathered from an object into a spectrum. By analyzing the spectrum, one can determine properties such as mass, chemical composition, and temperature. On the spectrum gathered from an object, there are lines imprinted that uniquely represent the elements that are present in the object. The mid-infrared instrument has a camera and a spectrograph that observe light in the mid-infrared region of the electromagnetic spectrum. These instruments will allow us to observe distant, redshifted galaxies, the formation of stars, and dimly lit comets. The fine guidance sensor helps the James Webb Space Telescope to point at objects precisely so that the images that it observes are high quality. The James Webb Space Telescope will be orbiting the Sun about 1.5 million kilometers away from Earth. It will also be almost as large as a Boeing 747, and the mirror is about 7 times as large as Hubble's mirror, which gives it an extremely large field of view.